Hopefully you can all see my screen. All right, we'll get started. If people join, then they can join in. Thank you for joining. So this is about deploying models in Oasis and the various options that we have available, which are plentiful, I'd like to say, because we don't dictate any one particular way of deploying Oasis, and that gives us lots of options, obviously, but it also can be slightly daunting. So what I want to do here is give some kind of indication of the common options and some of the resources that are available to help you make that choice. So in terms of agenda, I'll go over, first of all, just describe what the Oasis platform is. There are lots of different terms that are thrown around, and I think some people get confused between what the different terms are. So I'll explain a little bit about what an Oasis platform actually is at its core. Brief introduction to Docker, because we do use Docker for deployment. Most people, I'm sure, will be familiar with that, but not everyone is. So very quick introduction to Docker. And then we'll talk through the actual assets that are used within a model deployment. So outside of the Oasis software, what do you actually need from a model provider? Or if you're building your own models, what do you need to build yourself in order to run them through the platform? A little bit then on how we put all that together and what an Oasis platform looks like schematically. Some of the options on how we want to deploy it, sort of in-house or third party. And we've heard from 4 of the third-party providers already today, so I won't spend too long on that, but I'll just highlight a little bit about what I understand about the differences. And I know some of those people are on this call, so they might want to jump in if I get something wrong or if I miss something. And then, as I say, I'll point you towards some of the useful resources that you can go to after the session, because it's a relatively short session. I also wanted to just briefly touch on our development plans in this area that we're working on over the next kind of 9 to 12 months, which is moving to a more distributed architecture. So I'll explain a little bit more about what that means. Okay, so jumping into the components of an Oasis platform, just to try and clarify some of the kind of potentially confusing naming terms that we have here. So I'm sure most people have heard of all of these things, but I wanted to explain how they fit together. And where I'll start is right in the middle of this diagram over here with K-tools. So K-tools itself stands for the kernel tools, and it's the core calculation engine that Oasis uses. This is the kind of very high performance C++ components that run the actual Monte Carlo simulation itself and generate the ground-up losses and apply the financial terms and conditions to those simulated losses. And this sits right at the heart of Oasis. Oops, gone too far now. This sits right at the heart of the Oasis deployment. And historically, it's what a lot of people have thought of as Oasis, but we've built around that quite a lot over the years. K-tools itself has continued to be improved, but there's a lot more available now around it. So K-tools is really the calculation kernel, the high performance calculation that goes on right in the center. The Oasis loss modeling framework, or Oasis LMF, is really the Python wrapper that goes around K-tools and provides a number of services that just make it a lot easier to use. So the Oasis LMF package itself does a lot of the data validation, preparation. It matches the exposure data to the model data itself and highlights for you which data will be modeled, which won't be modeled, reasons for it not being modeled. And then it does a certain amount of data preparation up front to interpret the financial terms and conditions, get the data into the optimized format that K-tools requires it in order to execute the calculations, the simulation itself. So K-tools sits at the center. Oasis LMF really wraps around that and makes it a little bit more user-friendly. So K-tools is kind of C++ based, Oasis LMF is largely Python based. And then I mention in here as well what we call the model development kit or model development toolkit, which can be used kind of interchangeably with the Oasis LMF, but it's really a set of command line tools that we can use to run an Oasis model and take advantage of the Oasis LMF functionality. And this allows us to really run things from the command line, get quite detailed understanding of how a model is executing, which can be really useful for model development itself, because it means you don't need a fully deployed reference architecture to run the models in order to develop them, which is why we refer to it as the model development kit. But it can be used for a lot more than just model development. So I use it quite a lot for debugging. We use it if we just want to run some tests. It kind of strips away the complexity of a full production deployment from running an Oasis model. But importantly, it uses exactly the same coding and logic as we do use in a fully deployed model. So the MDK is embedded inside what we call here a Docker worker container for Oasis. So that's really key, actually. The same code is used for the development of the models and for the testing of the models by the people developing them, as we use inside a fully deployed version of the Oasis platform. So you don't get any loss of fidelity when trying to convert from a development platform to a production platform, because it is all exactly the same code. It's just the deployed platform, the worker container, is a convenient way of wrapping up all of that code so that you can, as a model developer, deliver it to a client or a software as a service provider. So that's really how the platform sits. What we have as the interface to the platform is the API. So the API is a set of instructions that you can pass to the Oasis platform and will be interpreted and executed by the Oasis LMF package inside the work container itself. And the analogy that I mean, people talked about APIs for a long time, and I, some time ago, kind of, you get what they are, but the best analogy, if you're not familiar with APIs, for me was always the restaurant analogy. And the API is really a menu. And as a customer, you sit on this side of it and you pass a request in, and the request is managed and sent to the kitchen in the background, who prepares your food and then delivers back what you've asked for. And you don't need to know how it goes on. You don't need to know what goes on. You probably don't want to know what goes on inside the kitchen when you order some food. But importantly, when you request something, you get something back. You don't need to know what's going on in the workings of it. And this is quite useful for us, because it means we can change what's going on in the background. We can change the way we do things without affecting the apparent execution from a user's point of view. So a user will put the same request in. If we change the way something runs in the background, they'll still get the same answer out. It may be quicker, it may be, a bug has been removed or something. But from a user's perspective, be that a physical user or a system user, they don't need to know that things are changing in the background. And again, going back to the kitchen analogy, you could put a new cooker in or something. It doesn't matter to you as a user of the system. So that's really the Oasis platform, is this kind of embedded grouping of functions that we have here, with the API as the stable interface, which systems or users can interface with from the outside. And we don't place any restriction on how you interact with those. We just publish a set of APIs. We do make available an open source Oasis user interface, which I've highlighted over here, which is very useful if you want to get up and running and see how the platform is working. It's fully functional. You can use it to upload exposure, run analyses, get results out. It's a nice user interface. We intentionally haven't designed it to be a full production user interface that you would use to run the kind of volumes that Max spoke about earlier on from Guy Carpenter. So if you're running hundreds and hundreds or thousands and thousands of analyses, it's not designed to help you manage that level of work. It's really a user interface that's quite nice, easy to use, helps you get data in, see how it's running. You can use it to evaluate the software. You could use it to evaluate new models potentially, or you could just use it for kind of casual use if you're not looking at using production level systems. But where people are using real industrial scale analyses, they tend to use a kind of system interface. So they'll have a separate system which will fire APIs off to the Oasis platform. And this is the way that most of the software as a service providers do it, and a number of the larger reinsurers who run internal Oasis systems take this approach as well, by having their own systems just interact with Oasis via the APIs. Okay, moving on. Quick introduction to Docker for those that aren't aware of it. And again, going back to analogies in the real world, which always helps me to understand things. The best one I heard was people kind of understand virtual machines or physical machines, and they don't quite see where the difference with Docker is. And the best analogy that I've heard is the difference between really a house or a housing estate and an apartment block. So virtual machines are more like a house in its own right. It's got all of the utilities and services wrapped up in itself. Docker behaves more like an apartment block in that it uses a central set of resources that are provided by the host machine, whatever it's running on. From the inside, it looks no different. So if you're in a bedroom in an apartment or in a bedroom in a house, you're just in a bedroom, you don't know the difference. But you know, it can take advantage of the central services of the block to behave much more efficiently. If you have 10 apartments in a block, they can generally use less resources than 10 distinct houses. So that's really the difference with Docker. And importantly, you can add more things to it. So you can just add apartments on top, in principle. I mean, Docker is named after container ships, and the idea is that to the outside they just look like containers, and actually they're called containers that you can just add. They all look the same to the outside, but they're effectively like very lightweight VMs, albeit a lot more efficient to run. And a few of the terms that you'll hear, which equally can be slightly confusing if you're not familiar with it, but we have the concept of Docker files, Docker images, Docker containers. So a file is used to build an image, and an image acts like a blueprint for one of these apartment blocks. The containers themselves are almost like the apartments themselves, but we can use the image to recreate containers lots of times. They can all look the same, but the image is really a blueprint. So the Docker file is the code that tells us how to build the blueprint, the image, and the image is then used to spawn many, many containers, and the containers behave as if they were independent computers themselves. The other thing we talk about a lot is Docker Compose, which is really a configuration system that allows us to consistently bring up many containers together. And a slide in maybe the next slide or the one after that, I'll show a little bit more about this. But when we're running any kind of production level system, we have to have many, many containers, or many of these kind of mini computers that speak to each other. The Docker Compose is that kind of configuration functionality that allows us to run them all together and tell them how to talk to each other. In terms of what a model is in Oasis, I won't go into the actual detail of how we represent hazard and vulnerability and all of that kind of stuff. That's going on in one of the other breakout sessions. But really, once you've built a model in Oasis and you want to deploy it, there are two things that you really need. One is a worker image. So this Docker image, which is the blueprint of the engine. And this contains any bespoke code that you use within your model or to map exposures to your model. And then we need to marry that up with the model data itself. So these are the representations of the footprints, the hazard footprints and vulnerability files, which can get very, very large, as a number of the model providers have alluded to earlier on. So we tend to keep the image and the model data separate because the data can be very big and the images, it's beneficial really to keep them very lightweight. Just going back to my earlier point of you might want to spin up many of these worker images to run lots of different parallel executions. You don't want to tie up your model data with your image as a single deliverable because that just makes it very heavyweight and quite difficult to bring up many containers from the back of it. So we keep those two things distinct, although they need to be compatible with each other. In addition to those, there are a number of peripheral assets that we need to some extent. I mean, they're not all they're not all hard needs necessarily. Model metadata is quite important if you want to deploy a system, because the whole system needs to know something about the model that you're deploying. There may be some particular runtime options that are specific to your model, some information about the type of perils that you cover, that kind of thing. So if there is anything model specific, it needs to go in that metadata, which allows the model to be properly deployed inside a system. Then we also suggest that there are some kind of QA type data sets that model providers supply as well. So things like test cases, reference portfolios, and expected results, just to make sure that any deployment is exactly as expected. And then generally, if there is any model documentation, that will be provided as well. If model providers are deploying to a software as a service provider, those software as a service providers will generally have some stipulations about what kind of peripheral assets they require. But the core assets are the model data and the worker image, and then the peripheral assets are really there just to make everything run a bit more smoothly in a deployment and ensure that it's deployed properly. Once you get these things, if you are deploying an Oasis model, you need to adjust your Docker Compose file, which is, if you remember, this is the configuration file that tells the whole system how to speak to all the other parts of the system. So if you're running this yourself, you will need to adjust a Docker Compose file in order to let it know that there is a new model available there. I won't go into that in detail because that could take a long time, but I'll point later on to some of the resources that are available that might help you understand how to do that. Okay, so when we actually deploy an Oasis platform, it is using Docker. The bits on the right here, the kind of dark blue sections, relate to what we were talking about earlier on. So there's the concept of a worker image that does the execution, has any model specific coding inside there. We also have the model data that sits alongside it. So this is the hazard footprints and vulnerability files and things. But that's a model in Oasis. How we hook that in is we have this conceptual kind of mid-tier, which incorporates the APIs that we talk about, and also a message queue to manage the workloads into these Docker containers. So when you spin up a platform in Docker, you tend to set this middle section up first, and then as you add models into the system, they will post that that metadata that we spoke to the message queue to let it know that I've got a new, whether this is US flood model that I pumped in here, and I've got a US quake model, and I've got a European windstorm model. As you set up these additional workers, they pass their metadata to the queue in order to let the mid-tier know that these data are available, or these models are available for execution at this point. The mid-tier itself, I mean, it's a fairly standard kind of API and queue system. We do also have this shared data store, which is quite important, because a lot of whilst the model data can be quite big, the exposure data itself that we're also passing into the system can be quite big. So rather than moving that around quite a lot, we tend to just drop it in a location, and then we pass around pointers to that location. So it's important that all of these workers are set up to be able to see a common data store. And then when I pass a request in to do something, that request sits on the queue until one of these model workers picks it up and starts doing the work. Once a model worker picks up a job and starts doing some work, it stops, or it lets the queue know that it's not ready to do any more work at the moment. The other model workers can keep pinging the queue and saying, I'm ready to do any work, is there anything there to be done? But the one that's doing the work will stop doing any work at that point. I mentioned over here as well the UI. I mean, the Oasis UI is in this diagram, but that could as easily be any other UI or any other embedded system that you have yourself. The addition that I'd add in here is this is horizontally scalable at this point. So the assumption that I'd made so far was all of these Docker containers and model data are on the same machine. We can set up additional machines that can equally hook into this queue. We can have many models on each machine. And in the example that I spoke about earlier on, when Model 1 work had started doing jobs and stopped telling the queue that it was ready to do more work, if we have a second instance on a second machine that also has Model 1 on it, that would keep pinging the central queue and saying, I'm ready to do some work on Model 1. So if I had two jobs for Model 1 that came into the queue and Model 1, Worker 1 picked it first one up, Model 1 and Worker 2 would be available to pick the second job up. So we can horizontally scale quite easily if workloads are getting bigger. We can just spin up additional instances with these Docker containers inside them, hook them into the queue, and they can start picking up those jobs and doing work, which is that's fine if you're monitoring a system. It's not very dynamic. It doesn't automatically pick up by itself, but that's what we'll come on to in a little while when I talk about distributed architecture and what we're moving towards. In terms of where to deploy, if you're deploying it yourself, really anywhere. We don't dictate any provider specific architectures. So you can deploy this on premises as long as you've got something that can run Docker. Docker runs on, it does run on Linux and on Windows and on Mac. So you can run a full Oasis deployment on a laptop if you wanted to. Be limited by the performance of the laptop, but laptops are pretty good now. It'd be more down to the model data itself, how much data you can store on a laptop. But servers, laptops, in the same way, equally able to be deployed to. And again, we don't put any restrictions on any cloud-specific services, so you can deploy to any cloud provider. I've listed the most common two that we see here, AWS and Azure. But there's no reason you couldn't put this onto Google Cloud or Alibaba or anything you wanted to. It's a pure kind of Docker-based deployment, which in theory should be deployable on any system that supports Docker. We have seen some examples of companies that have quite old architecture that doesn't support Docker, but I think we're getting to the point now where pretty much everyone uses Docker for some part of their organization. So yeah, anything that supports Docker, you can deploy Oasis on. We have deployed it on Raspberry Pis, which is quite nice to do as well, if people are aware of those. So they're little like microcomputers that cost about $40, but you can deploy Oasis and run a model on something as simple as that as well. We've heard from these four third-party hosting providers as well already, but I just wanted to touch on it again. So I'd hope that Oasis is fairly easy to deploy. Actually running the system, managing it, dealing with support, dealing with help desk calls, all of those things, licensing models can add extra complexity into actually running a production system, and that's where these providers come in to help out. So NASDAQ, complex exceedance, and impact forecasting all have platform as a service or software as a service or hosting provision available. Slightly different offerings from each of them, and they've all talked a little bit already about what they've done and what they offer. But so I won't go into too much detail, but I think from my notes from earlier on were, NASDAQ, they've got a lot of models available already. They've got a very quick uptime. They've got quite an established user interface already. And they offer some additional services around, which I don't think James mentioned, but there are additional kind of validation services and currency management services that are on offer through the NASDAQ platform. Essentially, it has Oasis at the heart of it, but they offer these additional services over and above the core Oasis functionality. Complex have just released QHelm, which is not dissimilar to what NASDAQ are offering. It's kind of software as a service provider. It's I think the point that Steve made earlier on is it's kind of embedded in a broader system. So there is a more complete kind of underwriting and insurance system that's being offered by Complex, and the Oasis offering within that forms a part of that ecosystem, but it isn't the only thing that's on offer there. and I think the term that he used that I quite like is this data-driven decision making. So it enables you to embed Oasis as a part of the broader suite of tools that you'd use, but all in one place. Exceedance, slightly different offering again. So they mentioned their on-demand cat modeling service. This is more of a transactional pricing type system. So it's a pay-as-you-go type approach where you don't necessarily license the model. I'm not sure actually, Complex didn't mention it earlier on, but I think they may be offering that kind of service as well, where you can pay for an individual analysis rather than licensing a model for a complete term. But it's quite a nice system. It's not provided as a user interface to a user. So if you do opt to use Oasis models through Exceedance, then it's a type of system where you'd send some data off to them and they would return to you a report on that data, depending on which models you want. So you don't actually run the execution yourself. They run the whole thing for you and provide the results with some analysis and intelligence on top of it. And then impact forecasting, and Chris touched on it slightly, but didn't talk about it for too long, but they now have the Oasis platform embedded within Elements as an option. So if you are already an Elements customer, or you want to, if you're planning on taking Elements on board, you can run Oasis models natively through the Elements UI. It will take the OED data and send it off to the Oasis APIs according to the schematics that we went through earlier on. So 4 sort of quite different offerings there. As I said, I think the benefits of these are more around kind of the support and the ongoing management of your system. So they all offer very, very good hosted systems with very good support services behind them. If there are any questions on any of the results, you can go back to a single provider, one of these providers, and they will manage a lot of that discussion with you back to the model providers or back to Oasis. It's generally a single point of call for a service, rather than if you do deploy an Oasis model internally yourself, then it's up to you to manage the support, manage the relationships with each of the different model providers. And I think it just takes a lot of that complication away by employing one of these providers to deploy and run your Oasis models. Okay, moving on. In terms of useful resources, the 2 places that we normally point people to are our GitHub repository, which is where we store all of our code and all of the documentation. Not very easy to see, but there is a kind of link here on our GitHub repository. So just github.com/OasisLMF. But this link at the top is to the main Oasis documentation itself. We do have repositories for each of the kind of embedded parts of the system that we mentioned before. So KTools, Oasis LMF, and the MDK and the platform itself are all available there if you want to dig into the code. The one that I would normally point people to in respect to deploying Oasis, if you just want to have a go at it, is this Oasis evaluation repository, which allows you to very quickly spin up an entire system in Docker. It provides a user interface. It installs an example model. So we have this Oasis PyWind model, which some of you will have heard of already, which is a kind of dummy model, albeit based on Hurdat data, but it's a Windstorm model. The evaluation repository is really, really useful for just getting something up and running very, very quickly and just having a look at it, seeing how it all fits together. All of the kind of diagrams that we've gone through already, they're just set up, ready to run with a single command. It embeds all of the Docker Compose configuration, spins up all the containers, gives you access to the user interface, gives you access also to an admin console and a Swagger page, so you can test the APIs individually if you want to do that. If you're not comfortable just going straight to the code and having to play around, or the technical documentation, then we do also have a YouTube page now, which has quite a lot of videos on now. Some of them are more conceptual, some of the ones you see here at the top, the future of cat modeling, but there are some quite technical videos as well, which take you through installing and running the system from the command line and deployment options within that. So the YouTube channel, I haven't provided a link because it's fairly abstract, the naming that YouTube gives to it. But if you just go to YouTube, Oasis LMF through Google, it will come up, and there's quite a lot of useful videos there. They're the main two areas that I would point you to. I mean, the other software as a service providers and platform as a service providers that we mentioned in the previous slide are also excellent resources to use, and they'll, I'm sure, be happy to speak to you if you'd like to understand more about their propositions. And then finally, what I wanted to just talk on quickly before we move on and open it up for questions, people that have any questions, is what we're moving to next. So we're just starting this project to build Oasis into a distributed architecture type system. What we currently have, for those who aren't aware, is Oasis will parallelize any executions across the available cores on a single machine, and this is quite traditional and quite standard. You know, so if you have a decent server with 16 cores on it, or 32 cores, and you run an execution, it will split that job 16 or 32 ways and run them all in parallel in order to make it run quicker and utilize all of the resources available on the machine. And that's the way most systems worked historically. The API kind of manages that workload in the mid-tier, but when you pass a request into the Oasis API, it will split that workload n ways, where n is the number of processes available to run the execution. But increasingly, and this is all, say, within that one Docker worker container that we talk about, this goes on inside there. Increasingly, though, the world is moving more towards a kind of distributed architecture using orchestration devices. And how this looks different is that we distribute the workload over lots of small machines rather than running on a very large machine and distributing the work across cores on that machine. And this can be useful because it's generally cheaper, generally more efficient. You know, you don't have to have a big instance sat around not doing very much for a lot of the time when you're not running anything. These small instances can be spun up very quickly, particularly in the cloud. I mean, you can just set them going, have them do their little piece of work, and then pass that work on to the next instance that wants to do something. We are looking at using Kubernetes, which is Google's open sourced orchestration device, which is, again, pretty much the industry standard now for orchestrating distributed workloads. And this just helps you to do, not dissimilar to what we mentioned earlier on with Docker Compose in terms of configuring how you want things to come up. The Kubernetes orchestration device, they also use the term Helm, which is a bit confusing with the Q Helm from Complex, but the Helm charts are ways of defining how you want Kubernetes to orchestrate your workloads. So if I send in a big job, it will split that job up into however many chunks make sense to split it up into. And this is useful because whilst previously I'd mentioned we have horizontal scaling, that we can add additional servers if we have a lot of workload going on. This can be done much quicker. You can access a pool of available workers and spin them up as you go. They don't need to be separate to the rest of your IT systems necessarily. So a lot of companies now are running large Kubernetes pools that you know, they run their entire IT infrastructure on, all of their different systems, and whatever needs the resource at the time can go and use that resource. But it allows you to scale the jobs much more efficiently and much quicker. So if I have a very big job that comes in, I can potentially throw a lot more Kubernetes nodes at it to split that job up into lots of smaller jobs, make it run much more quickly. It also, I mean, Kubernetes also helps you to handle, if one of these particular processes fails, the orchestration device allows you to decide how to handle that, where you catch it, whether you retry it, how many times you retry it, and if things are critical, then you need to fail out the whole job. If it's not working for any one reason, or if they're not critical, you can move on. But these are fairly standard utility tools now that are used much more broadly. And I think what we'd like to get away from is cat modeling being something specific that that only a certain number of people know how to use, and you have to, you have a machine in the corner that one guy knows how to use, and he's the one that runs all your cat models. It's separate from the rest of your IT. Increasingly, I think people are looking at just making it as standard as possible with the rest of an IT deployment, so that you can take advantage of the full set of resources that you have in your company. That's to come. Like I say, that's not available just yet. We'll be working on that over the next 9 to 12 months, I think. Importantly, though, the other thing I would just point out is it doesn't affect the API. So going back to my my restaurant analogy earlier on from APIs, the menu remains the same. If you're writing systems up against Oasis, nothing has to change there. What's going on in the kitchen behind the scenes is hopefully much more efficient and much more scalable, but the menu remains the same, and the way that Oasis interacts with any other systems or user interfaces remains exactly the same. It's just the way that the actual the food is cooked in the background changes. So so I guess the point here that I'm trying to make is really, don't hold off deploying an Oasis infrastructure to wait for the next phase. Things will always be changing. The reason we spent a lot of time last year, the year before actually, developing a really solid set of APIs is so that we can have a solid interface to the system, a solid and stable interface, so that it can interact with other systems without concerning about how we do the work in the background. That was about it. I think I'm about on time. We were aiming for 45 minutes for this session. I think I've taken 38. So I'll open it up at this stage for questions if people have any. I'll stop sharing my screen so I can see if anyone's on the line as well. People have any questions or any points or anything to add that I've missed off, maybe from the service providers?
Hi, can you hear me?
Yes, yeah.
Yeah, I was actually interested in the Raspberry Pi comment, and I was wondering, do you have any tutorials, and have you tried to also extend it to a Kubernetes Pi?
We haven't. That's what we're about to kick off this project for. I think some of the software as a service providers are running Oasis in Kubernetes already, albeit a kind of halfway house of you kind of spin up a single node which does the full work as if it were a container in its own right. Well, it is a container, but no, we haven't really toyed around with that too much. We did a little bit of work on just using Docker Compose as an orchestrator to show how we could distribute work over multiple Docker containers, which is available as well on our GitHub page. There's a architecture 2020 prototype repository that shows how we do that. But no, the next phase in our development is really the Kubernetes development. I had considered as a gift for people that want it, just sending out a Raspberry Pi with Oasis installed so that people could just have a play around with it. I thought that'd be quite a nice little present for people that do want to do it. But no, we haven't done much beyond just running the standard Oasis on Raspberry Pi.
Okay, and do you happen to have a tutorial on how to get it to run on a standard Pi? That would be something I'd be interested in doing.
We don't, but I'd quite like to do one of those. I might just do a video on it at some point. But
Okay, cool.
It's no different to anything else. I mean, you can run Docker on a Pi, and then it's just you can run the evaluation repository straight from there.
Okay, thanks.
Okay. Any other questions? So there's some chat there. Did someone? There you go. Sorry. There was a question in the chat, but I think it's the one that you just asked. Okay, if there are no other questions, then we'll probably wrap up. I'm not sure, is Julia still on the line? I can't see her on here actually.
I'm still here.
Oh, you are there. Okay. Yeah. Are we going to send out slides after the meeting? Are we going to make these available, or are we just going to make the recordings available?
Yeah, so we make the recordings available, and we can also make the slides available.
Okay.
It's no problem, sure. And then again, if anyone has any more questions, just email us.
All right.